So my name's Marc, Cenac. I work for a company here in New Orleans. Well, we're based a lot of places because we're a remote company, but they're called Boundless, and so we work on geospatial software. And to that end, I've been working with them on building a mobile data collection platform, and then the back end of where all that data goes, and then pushing that around. And so that back end part, we've started writing in Clojure recently. And so I'm pretty new to Clojure, but I've been programming in Java for 7 or so years, so I have some experience there, and that helps out a lot if you're going to be programming in Clojure. It is new to me, and if there's something funky, I guess we'll get started. Actually, let me get a show of hands. Who's used a Lisp kind of language before, or Clojure? Okay, cool. I'll do a little bit of overview of Lisp. But I'm by no means an expert at this. Eric is, but I've been doing this a few months professionally, and I like it a lot. So functional programming is awesome, and so is Clojure, and so is Clojure Spec. So let's get started. Okay, cool. So what is Clojure Spec? Well, it's a library. It's a new library, and in Clojure, you have the core language, but it's a dynamic language. So that means that you can extend it in certain ways. And so Clojure Spec is actually just another namespace, but it's a collection of functions that you can use, and it's gonna be part of the core distribution of Clojure. So when you use the language Clojure, this will be in it eventually. So right now, this library is still in alpha, and they're going to be releasing it, or this version of it. 1.9, they're going to be releasing that sometime this year. I don't know exactly when, but I would guess in the next 6 months. So this is previewing some of the new features that they have. And because Clojure is a dynamic language, you don't have to specify types like in Java or other languages that have type systems. So it's dynamic, and Spec kind of functions. It can function like a type system a little bit. So for instance, if you want to check that a data structure like a hash map has a certain set of keys, right? Like properties, you have keys and values. You want to make sure that certain keys are in there before it's valid. So it kind of works like a type system, but it's not quite that. It's actually better in my opinion. But the idea of spec is that you define these things called specs, and they're specifying things about your functions or the data, and that turns out to be really useful because of a lot of the other benefits that you can get once you spend the time to initially spec out your system. So what I think is the most valuable part is generative testing, and tests are essential to quality, and that's something that comes from the docs, and I believe that, and you can't, if you work on non-trivial software, eventually you need to write tests so you know if you are breaking something when you introduce new features or when you're refactoring something, and they give you the confidence to be able to release new software faster, and that's really powerful. So you need to write tests, but who likes writing tests, right? Anybody here like writing tests? I would say I kind of like writing tests. But the idea about generative testing is that you don't have to write these tests, really. You write the specs, and then Spec can generate tests for you, which is cool. So instead of saying, hey, I'm testing this function, when I give it this input, I expect this output, you can write those, but it has a low effectiveness to effort ratio. So the juice isn't worth the squeeze sometimes with testing, and a lot of people, if you're going to tell a customer something, hey, we're going to spend 2 weeks writing tests, they're going to say, screw you, you should write tests anyway, and we just want working software. So this allows you to write systems that are more correct, and it helps you build these tests, and that to me is one of the best parts about Spec. But you also get all this other stuff. So you write the specs, and you get data validation, right? Does this data match this spec? And then if it doesn't, you get error reporting, and it gives you very specific error messages, which you can, I mean, I'll show you some later on. You might have to parse it out and make it more user-friendly, but the whole idea about specs is that it's specific, right? So it's telling you exactly what went wrong. So that could be useful for error reporting. And then the other thing is, so generating test data, which is great because a lot of times you want to be able to do that. So just generating test data and throwing it at your system, or just generating it for tests. Once you write a spec, you can generate data off of it, and I'll show you some of that. So those are some of the why you might want to use this. It's but it really is I don't know. It's a powerful thing that I like. And also, the idea is not new. There are other systems that are out there that do this, and this is going to be part of the core language. So that's kind of one of the reasons why I wanted to go with it. But if you want to, Eric has a thing on Lispcast, comparison between this library and something else called Schema, which came before and does some of this similar specking of the data. So there's advantages to using both. This is still pretty new, but I think that this one's more powerful, so we decided to go with that. So what is a spec? The most basic thing is it's a logical composition of a predicate. And a predicate is just a function that takes one argument and it returns true or false. So and these are functions that are in the Clojure language, like even. If you want to test if a number is even, you give it a number and it returns true or false. Or odd, or positive integer, or does this contain something? Or is this a string? Is this nil? All of those are predicates. And so specs ultimately are taking a value and giving back a Boolean. So you can write your own, and we'll get into some of that later. And then you can combine them. So now you have this kind of logical combination with these operators. So you could say this and this or that, not this and this. And so being able to combine that into one spec, it's powerful to be able to combine that. And also they can be regular expressions. So that's pretty cool too, because you can say, does this string match this regular expression? And you'll find many, I mean, if you've used regular expressions, you know that they're very expressive, which is good. So we'll get into some of that. I'm going to show some code in a little bit, and then we'll play with Clojure in the REPL. But this, well, you can see that. I don't know if you can read regular expressions, but that's one that I came up with for tonight. Okay, so how would you use it? Okay, let's stop and do a little bit of Lisp so you can read this. So Lisp works by Lisp processing. So it's going to process each one of these instructions that are within the parentheses. And that's called a form. Is that right? So far? Okay. And then the first thing inside of the parentheses is the function. So you're always going to have a function, and then the arguments come after that. And then the other thing is once it evaluates that form in between the parentheses, you're going to get a result back. So that's what the REPL is read, evaluate, print loop. And that's Python has one, and I think Ruby has one too. But they're very useful for interactive kinds of development, and Clojure gives you this. So if I wanted to require a library, specifically this library, spec, this is how you would do it from the REPL. And then here's some predicates. So predicates are like even, positive, and even, and you can see how I was saying you can combine them. So with spec, you can check if it's valid, you can combine them, and you can do some things with regular expressions. So let me hop in the REPL and show you guys some of this stuff. Oh no, let's see. Give me a second. I'm going to have to get out of full screen real quick. All right, exit full screen. I'm going to put the code. Put the code over here. All right, let me make this bigger too, so you can see it. How do you make this bigger? Does anybody know?
Usually just plus, like command.
I tried command. What is presentation, man?
Full screen.
Maybe.
I don't know.
Deleted. That's
I can't see it. Let's see. What is full screen? Does that help? You can't really see it.
It's in, I think it's in preferences.
It's in preferences?
Not understanding how Paul works.
Look, there it is, size.
Where?
Right there. Right where you're at.
Oh, this, yeah.
Yeah.
A little bigger.
Well, that didn't. Come on. That's,
Okay, to reload it.
Wait, are you saying that they have a setting for the...
really? Come on.
Yes.
Because you guys can't really read it.
Maybe you want your code big.
Let's see. What did you say? Presentation, man? Ah, there we go. Oh, but you can't see the, yeah, well, let's see if I can pull it up. No, this is not good. I need the REPL too.
Can you view REPL?
Sorry, let's see.
Maybe you can pull out a separate window for
Yeah, you think I can do that? There we go. Cool. So this is the REPL. So what I just did here is I highlighted it, and then I'm going to run a command to say, oops, I'm going to evaluate it in the REPL. Boom. So I said require this namespace, and it returns nil. Doesn't mean it failed, it just doesn't return anything. So now that I have this namespace, we can go ahead and say, okay, is this valid? Let's see, is this the trash can? We'll have to do some of this. Okay, cool. So this is checking a spec for a value. So this is useful for a lot of different things as we go through. But this is your kind of data validation. If you want to see if something is valid, you can use sValid, or you can use the function valid question mark. So let's see, we'll put the regular expression in there, and we'll say, does hacknight match it? And does it? Yes, okay. And we'll say, does slacknight match it? Boom, yes, okay, cool. But if it's not, if it's just night, this isn't going to be valid, right? All right, so I'm running all this stuff, and this is evaluating this function in the REPL, and it's returning false. So regular expressions can be predicates or specs, and that's kind of the root of what a spec really is a predicate. So it's kind of matching something. And then the other thing is you can use this function to register it. So once you start dealing with it, right here we weren't really doing anything. Like this is just defining it in a namespace, but this defines a spec. So it takes a spec name and then whatever the spec actually is, and it registers it in this global registry. And that's very useful because you can use it across your whole program, and they're kind of uniquely defined specs. So if I register this right now, cool, now I have this thing in this namespace, and the namespace you can see is right here. So here's the hacknight spec, and if I wanted to do this, let's say I could say, here, you can type down here too, sValid, and then I can say hacknight. Well, let's see, you actually have to do it like this, which means it's in the current namespace. Oh. And that's true. Okay, cool. So there you go. This is some of how you would use spec to check for some validation. Also, you can use sets. Sets will also be valid, or they can be used for validation. So you test the set membership. If I did stuff, it wouldn't work, right? So that's kind of useful. So sets, all right, so let me go back to, let's see, let me go back to the slide. this. Okay, cool. All right, so we saw that. Yep, so this is how you define specs. Defining specs for a map. So maps are a data structure that you're going to use a lot. Oops, let's see. Sorry. So maps are a data structure with a key and a value, basically. Or they have key value pairs, and that's useful. You see them in a lot of different programming languages. But in a type system, you could specify exactly what the type is, so it could have certain keys and values or something like that. And in spec, you can define, or you can describe what data must be contained inside of the map. So it's kind of like a contract for what it looks like. And so this is a spec for, so we're building up a spec, and we're saying, like right here is where we're saying define a spec called user spec, and it's specing a map. And so the map, I can say, well, I need these to be these keys are required, and these keys are optional. So this is how we might spec what a user looks like. Also, I mean, don't use this regular expression for real, but it's a pseudo okay. But you can kind of see what we're doing here. We're building up some specs, and then we're specing a map. And so you can also say valid, or you can explain what's going on if something's wrong. So here, let's just show some of this. Look at the code. All right, so let's load this stuff up. Boom. All right, cool. Let's load this as the map spec. So remember SDEF is registering this thing globally. So it's always going to be here if I need it. So this is me, this is my name, and let's put that in here, and then I'm gonna say, let's see, first off, so let's see if this is valid. So I'm gonna say valid, and then you give it the spec, user spec, and I'm gonna say user. So is the user valid against this spec? And it's not, so that's not any good. But we have explain, and explain will tell us what's wrong. So it says, here's the value, and this value fails this spec, and it gives you the predicate. And which predicate failed? It says, hey, it doesn't contain a password. So we need users that have passwords. So if I add one, and this is a way of, this is a assoc. This is another function. So you say, assoc this thing, give it a key and a value. So you're saying, associate that with this user. And if I add a password, it's true. So this is okay because it's a valid spec. So that's useful. And you can imagine I'm going through some kind of basic ones, but anything that your data looks like, you can use this. I mean, we're all going to have users, and you can get complex, like first name, last name, middle initials, and later on I'll show you, like, you probably want something a little bit more specific than just a string when you're doing a password. I know you probably have to enter like uppercase, lowercase, special characters, numbers. So you can add all that stuff, and then that way, whenever you're trying to validate when a user submits something, you'll know if his password's valid or not. So this is a way of doing that in Clojure. Okay, let's see. Let me go to my next slide. So now that we have these specs, so this is about defining specs. So we saw maps, we saw predicates, and you can use sets too. So just with using that, you can do a lot. But the cool stuff is that once you write the spec, you get all this stuff that I was talking about earlier. So one thing that's useful is generating data. And each spec is going to have a default generator, usually. So you'll be able to generate data that matches that spec. And so here, let's show you some examples. And then this is in the Clojure Spec Gen. And so generating data is very useful. And so this is useful for tests or populating your database. You could also do it for like nefarious purposes if you wanted to like write a password cracker or something. This would be a very good way to generate lots of passwords that you could maybe. Anyway, I'm not going to encourage that. But all right, let's go over here. So let's see. So this is about
Test the security of your passwords.
what? Yeah.
You can test the security.
You can test the security of your. You can see how easy your passwords complexity requirements are. To be wrote. Let's see. That's clear. Okay, cool. So if you wanted to just generate, so sgen and S is this namespace for Clojure Spec. But if I want to generate something, you need a generator. So I said each spec has a default generator usually, and this is how you would get it. You say, hey, get the generator for if it's a string. So you can see this returned the function that's the generator. And let's see, so if you say generate, and you give it a generator of a string, it's going to generate a random string. All right, so there's a random string, and if I do it again, boom, there's another random string. Maybe I'll do it like this. That's better. And so it'll keep doing it, right? And you can also do, like, there's lots of different built-in, and I would call these predicates. And then there's different generators that you can have. So this is the same as this, just in a different namespace. But if you can see, if you get generic, look at all this junk, right? It'll just keep generating this stuff. But what's really useful about this is imagine if you threw that data into your test, right? This is where it's going to get more valuable. You're never going to write this stuff if you were going to write a unit test. You would never generate this and put it in your input. And you don't know how your program would respond. But this is what makes it valuable. So generate is one way of doing it. Another way is you can say sample. So generate generates one thing. So let's say let's generate an int. The sample will generate a few of them. All right, so this is cool. All right, so let's generate a user, because we have a user spec, right? Wah, wah, can't do that. And so it's saying, hey, what's going on? I can't satisfy the such that predicate after 100 tries. So it tried 100 times to generate something that matched the user spec, but it wasn't able to do that. And if you kind of go through this, so let's say, was it the email? Yeah, it was the email. Because if you tried to generate something, whoa. All the other ones were just strings, right? So if we just tried to generate a string, or a password, let's see. So this will generate a password fine, because it's just a string. But the email is a regular expression, and the regular expression that I used is sort of difficult, sort of, but it doesn't have a default generator, so I can't create one. But luckily, this dude wrote a library that allows you to do that, so that's pretty cool. So you can pull this in, and you can say generate string from regex. So you give it the regular expression, and now you're gold, and you can generate all these email addresses. And if you wanted to get more complex with this, you could. You could say, hey, I want to make sure, like so this is just generating random data. If you want to generate actual test data that maybe would, people can go to your site and look at, maybe you want to make sure that this string is a top-level domain. So there's only certain top-level domains that you can have. Well, yeah. And so you could change this instead of just being a random string, which matches the regular expression. You could change that. So generating sample data is always pretty useful. And if you're trying to generate it with a regular expression and it's not able to do that, and you get one of these errors, which this happens. It just means you're not being specific enough. So you have to figure out why, and then you have to be more specific. But if the generators that we've done so far, these default generators, if they don't work for you, that's fine. You can write a custom generator. So that's cool too. So, and this is how you would write one. It's kind of, so I'm going to redefine the user email spec, and I'm going to say with this generator. So it's still going to be an email, but it's like what is it? So it takes a spec. So this is an email that says, does it match the email regular expression? And then here's our generator function that we used up here. Right. So if I redefine this, I'm going to say, let's make the email more specific. Now if I try and generate a user, it should work. Boom. Okay, cool. So we can just generate users. And if I say sample, we'll generate a bunch. Boom. Cool. And you notice, like sometimes it'll give you, like this isn't any good. We don't want to allow that. So we're going to have to change that later. But you can see, so this tool and this using the REPL and using spec, this is helping you build a system that's more correct. And you're thinking about things that you wouldn't have thought about as you're doing this kind of interactive development. And this is one of my favorite parts about working with Clojure is this REPL kind of development. And spec really helps with this as well. So yeah, generators are awesome, and you can have custom generators if you want. So let's see, some more custom generation. So let's load this guy up. So if you've used, anybody used Heroku here? You ever had to log into the database and trying to check it out? It's usually some kind of random string. But if it's Postgres, then you can only have certain kind of table names. They can't start with numbers. And there's a couple other things that you can't have. You can't have special characters, but let's just say this is a SQL column regular expression. So this is maybe something that I want to use to generate random SQL column databases. And so here again, I'm saying, here's the with gen function. So this is building a custom generator for this spec, and you just say, hey, it's got to be greater than 5 in like the length, and then how are we going to generate it? Well, we're going to generate it from this regular expression. So if we do that, boom. So that maybe starts to look like what you might log into. Maybe that's how they do it. I don't know. But this is how I might generate some SQL compliant names. So I'm sure that you could think about lots of things in your own systems that this would be useful for. All right, so let's see. And then here's another way to build a custom generator. So sometimes this might get hairy, this generation function. So right here we've seen it, and we've just used this guy's string from regex, which is very useful. But maybe you want to do something else. Like I said earlier, maybe you want to build an email generator that's a custom one. I didn't get completely done with this, but I was going to make this a top-level domain. But what you can do is you can say, you still have the spec, but then you can create a custom generator with this thing called fmap. So fmap takes a function to apply to each thing that the generator generates. And then the next argument that it takes is a generator. So in this case, it's maybe this will be clearer. I'm not sure the best way to lay out this sometimes, because it's all nested and I'm still learning, but this is how I have it right now. But the idea is that this thing's a tuple. So a tuple is a kind of like would you call it it's not a list really. It's like a homogeneous grouping of values. And so in this case, we need 3 strings, right? You need like a name, and then an @ sign, and then a domain name, and then a dot, and then a top-level domain. And that's kind of what an email address looks like. So here's a function that's going to take this thing, which is the tuple that's generated by this generator, and it's going to give me back a string that says this random string at this dot this. So I could redefine it here. So this is just a function. So I'm saying def n, that means define a function. All right, so we define a function, and then I can redefine the email spec. All right, and if I wanted to generate some emails, I could do that. Oh, I can't do it. Let's see if I'll try it again. It doesn't like it. Yep, so sometimes it doesn't work.
I don't think you should.
See, look, there it goes. What's that?
Oh, never mind.
So this is just me explaining FMAP. This is not the this is not the best email generator, but as you can see, like it tried a whole lot, and I wasn't specific enough. It got one eventually, but so this means I need to be more specific about what I want in here, and it also this is going to generate a bunch of random email addresses, but it also needs to match this regular expression. So it's not doing that here after 100 tries. And you can give it more tries. You can say, try 1,000 times. But eventually, and you'll probably find this as you're getting more and more specific. And I think there's a fine line between getting too specific, because then you're just testing like your happy path data, versus part of the reason this is valuable is it generates random data that you wouldn't think of. And that helps you write better tests, because it's testing cases that you wouldn't have thought of. So eventually you'll need to write your own generators, and this is some ways how you would write custom generators for these specs. And actually, since mine was so bad, I'm going to go back and change this. Let's see. I like this one better. So let's redefine that one. Boom. See, so this generates samples easier. Okay, cool. All right. But next up, if you're looking at this, it's like, hey, the password, that's no good. We don't want to allow valid users to have no passwords with 0. So this just says, hey, make the user password, make sure it's a string and it's in the range of 10 to 21. All right, so this is, and some of this is, if you haven't seen Clojure, maybe it's harder for you to read this, but again, it's always the same thing. Like if you have a parentheses, this is always the function, and then this is an argument. This means it's an anonymous function. So again, here's your function, and then you have some arguments. And then this is another function which has an argument, and then the % is the value that goes into the anonymous function. So you could think of it, I don't know, this is just some syntax sugar, I guess. All right, yeah, so I define this. All right, so if let's try this. Okay, well this was valid before, but it's not valid anymore because we made the password complexity. And you can explain why it didn't work. So it's saying, hey, it's failing this predicate. It's not between 10 and 20 characters. So if I do it like this, and I associate the value onto it, it's going to pass. See? So, as you're building these systems and building up the specs, it's pretty useful to be able to have the REPL. And then so here's some more generating of sample users. So you can imagine if you wanted to generate this for your tests or put it in your database, how that could be useful for you. Let's see what else I have. So we got generating data. Okay, we already saw what happens when you say, can you be more specific? Okay, cool. So the next part, this is my favorite part, and I'm still learning about it. So I'm excited, and I'll show you what I know so far, but I'm no way a pro. And also, this is alpha, so there's still bugs, and I found at least one. They know about it and they're working on it, but this is kind of part of being on the edge. But generative testing, I think, is just this really powerful concept, and it's not new. So Clojure is a functional language, and there's some other functional languages that have had this concept before. This idea of generative testing, and in Haskell actually they had a library named QuickCheck, and that's what inspired most of Clojure's implementation, but Erlang has it as well. And So the whole idea is that instead of writing these unit tests, you write specs that generate the tests for you. And that's why it's called generative testing. And to me, that concept kind of like clicked in my head, like, oh wow, I don't need to like write and maintain all these unit tests. I get all this stuff for free if I just write the specs, and then I get validation, and then I can generate data. So all of that combined, I think, makes it it ultimately makes you more productive, and it makes you write systems that are more correct. So yeah, I mean, it shouldn't be underestimated how easy it is to do this stuff in the REPL. So when you generate tests, instead of all of what we've been talking about before is speccing data. But when you want to generate tests, you're speccing a function. So you specify what the arguments look like to that function. So you give it a regular expression spec for that. And you define a spec for what the return value of that function needs to be. And then you can have a relationship between the args that were passed in and the return value. And so right here I'm saying, hey, write a spec for a function called findUserById. Make sure that it accepts an ID that's an integer, and that it returns something that contains that doesn't contain a password. And then contains is also used on a map, so we're returning a map of the user that we found with this ID. And then this is saying, make sure that the ID that we returned on the user, I mean, this is kind of, I mean, it's not testing much, but this is how I'm just showing you can get access to what's returned. And, so maybe if you were writing an adder function, you would want to make sure that, the two numbers that you sent in are greater, than the number that comes out. So something like that. And then to generate tests, once you define a spec for the function, you generate tests with check. So you can say, Clojure Spec test check, and then you give it a symbol to this function. And then the other thing is this function needs to correspond to a function that's in your code. So let's go back and look at the code and do this. All right. So this is a test function, and so I'm saying pretend we not save to the DB. Pretend we fetch from the DB, and we get back a row. This is a function. It takes an ID, and it's going to say, let's return a row. And this is what you would get back from the database, and I'm just making it up. Let's making up the ID, or this is the ID that's passed in. And then what you get back from the database, if you're doing a select all from users or something, you're going to get all these columns. So I added some other ones. And kind of like I showed you assoc before, this is dissoc. So this says, hey, from this row, remove this key and this key. Because when I return this, I don't want the user. Maybe I'm about to pass it back in an HTML or HTML response. Also, the password would be hashed, of course. But let's define this function. All right, and let's define a spec for the function. And I showed you this earlier, but this is making sure that it doesn't return with a password. So if I say findUserById, boom, this would work. Now, if this function, let's say I forgot to do this, right? Let's say that I wrote my spec and someone changed the function. I don't know, maybe there was like a sanitize function, and that sanitize function got refactored, and someone forgot that. They were like, oh, why isn't the password here? We want to return the password. So if that happened, let's see. Let's redefine this. So I'm going to show you it's like the bumpers. So if I tried to do this, let's see. Oh no, hold on. Oh wait, oops. If I did that. So let's say the function did return a password, and we don't want that. This is how. See, so now the password's returned, right? So if we wanted to test, this, what we do is we instrument. So instrumentation will turn on the checking of the args. Let me get this as instrument, and I'm going to say instrument by user ID. So this will turn on the instrumentation, and that means that if I try and do this, wait, this should, oh wait, what is going on here?
Oh, I think you read that function.
Did I not? Let's see. Sorry. Doing it live. Okay, so I spec the function if I sort of find user by ID. Oh, the input is valid. Sorry. So instrument, this isn't a good use case. This isn't a good demo. So instrument just will turn on the checking of the args. So you can do this at runtime, and that is useful. But I'm not actually checking, like, okay, let's see. So this needs to be an integer. So if it wasn't an integer, let's say I passed it in as a string instead, it would, what? That shouldn't work.
Is there always,
Oh, there it is. Okay, cool. I had to re-instrument it after I redefined it. Okay, so if I try to pass it in as a string, it would say, hey, you can't do that because it needs to be an int. And of course, this is a very specific error message that you need to parse out. But if you read it, I think it's kind of clear. It's just a lot. It's specific. Okay, cool. So if you wanted to, so this is like the big payoff finally. So is you can check this function a bunch of times, right? And then it will tell you if something's wrong. So this is telling you, if you tried to check, it's going to generate a bunch of, also I put this in there so you could see. It's finding user by ID. And look, it already gave me some stuff that I probably maybe didn't think about. So in my spec up here, I'm saying, hey, I want to make sure it's an integer. Well, this is an integer, and this is never going to be a database ID because it's negative. So that's good. Now we can improve it. So let's change this to positive integer. Cool. Let's see if I, let's clear
See
this.
that box with the blue arrow there, or the purple arrow?
This?
Press that, yeah, it'll follow. Yeah, press that, there you go.
Yeah, okay. All right, we got some more things. Oh, it still has the password. Okay, well, we got to update this. But I mean, this is what it's like to develop with a REPL and Clojure.
do you have to select everything?
I haven't figured that out yet. So like if I put it right here, I think it will evaluate everything within the parentheses. Let's see. Yeah.
What if you're inside the print? Like, what if you click right where you're...
Like if I did this, this would probably just print the, oh, okay, it does everything. Cool, thanks. So I just figured out how to do the key bindings the other day. I'm still new at this. Okay, so find user by ID. Okay, printing find user by ID, yes. Okay, so let's test some more. So generate some tests, boom. So here are all the tests that just got generated. And that's useful. You see that we've changed some things. So now we have all kinds of random integers coming in here. We don't have any negative integers because we changed that, so that's good. And at the very end, it's saying that the result is true. So, and we ran 1,000 tests. So this isn't maybe as useful, but what this is saying is that we've ran 1,000 tests for that function, and it's behaving as expected. So that's like writing 1,000 unit tests, which is great. So you can use summarized results to kind of tell you a little bit more useful information here. And also, if you wanted to run more tests, you can give it options. So you could run 5,000 tests, and those all passed. And you know, this is an easy an easy type of spec that I've showed you so far. But, oh wait, one last thing. So, all right, so we've talked about generating tests, which is one of the coolest parts, I think. And then you can also, you can say this thing enumerate namespace. So what this will do is this will give you all the specs that are in a specific namespace. So what you can do is you can combine this and say, run all these tests for all the things that we spec'd in the namespace. And so you can have like basically like a one-liner that will run all these, it will generate all these tests and run them for you. So that's cool. I'm going to pause right here and ask for questions. Anybody? Yeah.
That's kind of like a little question. So,
Sure.
I mean, it seems like this spec could be used for, I mean, especially when you're saying that this function should take a integer and output like a string or something like that. I mean, could that be used in like a text editor to like do code time validation? I mean, kind of like I know a lot of the static type languages have that using the compiler.
Yeah. Well, let's see.
I wonder if anyone's like, especially like IntelliJ, you know, maybe they could write something.
Yeah. I know that they, let's see, I mean, do they give you dots? Let's see.
Yeah, maybe it could be like Pi. Pi spec.
Oh yeah, sorry, I forgot about that. If you write a spec for a function, it will generate documentation about what the arguments are too.
Fantastic. Yes,
Yeah.
That's what I was asking.
Yeah. So this stuff right here, yeah, all of that would be generated by spec. Forgot about that. Who cares about documentation? No, I'm just joking. I haven't actually tried to do that, but I've heard that that's possible. And that's part of the reason you might want to
And
use it.
part of the release of 1.9 is they want to spec everything in Clojure and the language core library. So that should happen.
Okay, that's,
Every macro will finally give a clear message.
Right.
Something long awaited for it.
yeah.
So Clojure is a functional language, right?
Yes.
So what did you say spec actually? What is,
So spec is a library that's part of Clojure,
okay.
or it will be.
Okay. So spec creates like its main function is to create like generators, right? Or is that one of the functions?
So it's about, you know, specifying the data shape and specifying functions. So it's about writing metadata about your program that allows you, and then once you do that, you get things like this where you can generate tests, or you can generate data, or you can do validation. All of those things are part of spec.
So is there any languages that you have to know before knowing how to use spec? Or
No.
it's its own language. I mean, as
Uh,
far as
So spec, all of these things are just functions that are in the spec namespace. So like this is, all of these things are just, you know, this is just code in Clojure Spec test. Let's see. So all these things I was showing you before, like fdef, this is going to, you know, takes a symbol defining the function, and this is how you would spec. So these are just functions that are going to be added into the core language. So you don't need to you don't even need to download this as a library. You just say use Clojure. Let's say, do I have? Yeah, if you just add this, and this is the alpha version, as a dependency, you'll get spec.
Can you, earlier on, there was in the map that was returned from one of those functions, there was something called seed.
Yes.
Can you explain that to people, what that does for you?
This?
Yeah.
No, but you can.
So when it returns this is so they're reproducible. So if you do find a spec that fails, because it generates them in a systematic fashion, if you keep that little number around, you can regenerate the ones that fail, basically.
It's random, but
Yeah.
determined.
Yeah, random determinism. Yeah.
So seed is like an initial value that you could give it to. Okay. Interesting. Yep, I learn something new every day. Okay, so that's pretty much it. I was going to go through something a little bit more useful. So at my job, I do a lot of geospatial software. GeoJSON is a common format, so I was going to spec that out real quick. Unless anybody had questions. You're good? All right, let's just do a little bit of this. Go through this real quick. So in GeoJSON, it's a JSON format, but it defines some specific keys. So what you have is you have a feature, and a feature needs a couple of things. So it needs to define a geometry. That geometry, actually, doesn't the geometry need a type? Huh, now I'm confused. Maybe I did this wrong.
You have type 1 geometry.
Oh, wait, there it is. Yeah, okay. So wait, I don't actually even need this one. I just need a geometry and properties.
Feature doesn't have a type.
Feature does have a
This
type.
is gonna fail now.
Look at this. Look at me. I defined type twice. This is wrong.
So you need a prefix.
How about that?
And in your map.
How about geometry type?
I'm only doing points. So this is very basic, but this is just for points. But let me show you, this is what it's like to develop some more. So I defined all this stuff. Let's see. So yeah, GeoJSON is a feature. A feature has a type.
Wait.
What?
Would you change in the map, you change it to point type?
Yeah.
That's the name of the key, not the name of the spec.
Correct. You
What?
can change the spec too.
Right here?
Yeah, what I'm saying is, it's not a spec, that's the name of the key.
This is the name of the spec.
That's the name of the spec.
That's the name of the spec, the other one is the name of the key.
This is the name of the key. Ah, this?
Yeah, like, that's just a name, it's not a spec.
Ah, I see what you're saying.
No, you don't say.
No, I don't.
Get rid of the point hyphen.
Wait, what? Right here?
Yeah, remove the
get rid of
point,
the
just
point
do
hyphen.
type.
What do you mean?
That's right.
What are you saying?
In GeoJSON,
In GeoJSON,
for a geometry object,
for a point, for geometry.
has the name of the key is point hyphen type?
Oh, yeah, no. Yes, the name of the key is
Type.
type. But wait, the name of the
It's broken.
feature is also type too.
No, that's a separate thing. That's the spec. That's just the name of the spec.
But I want the keys to.
You can't specify the value types. You can't give a spec for the values of that.
Okay, so is it like this?
No.
No, well, I don't know. I
Right.
don't know if you need a namespace on the keys.
Oh, let's just see. Also, I wrote this right before I got here, so this might not even work. Also, I'm trying to do this right now because I want to generate some random data, and so I started working on this earlier today. Let's see. All keys.
All keys must be-
So wait, if I make this point type, I see what you're saying. If I make this point type, this is going to generate point. It's going to say point type is the key,
Right.
right?
It's not saying anything about a spec. It
Uh,
is key.
It's both.
Yes, he's saying you don't want this. You want this to be called a type. Okay. Okay, yeah, well, I'll need to fix that. So I'll need two different.
You need to use the namespace.
Yeah.
Use the namespace feature, do feature slash.
Yeah, you went like this. Right?
Yeah, just one colon.
And then this goes here. And this, I'll say point type. Right?
Yeah.
Oh wait, how do you say it? You can't specify what the key name is and what the value has to be?
I was of the,
There is a way.
yeah, I thought that it was specifically saying that we're not specifying the type of value. That you only say what keys it has, but I guess I'm wrong because it is generating the value point there.
What's that? I'm still getting, yeah. Okay. Yeah, so that looks right. Sort of. So the other thing is, as you can see, like I just specified map for the properties, and this is going to give me a bunch of junk. So as I'm going through this, I'll need to make it better. So this is all I was doing, but you can see if you're using this, there's a lot of use cases for generating this type of data. And you're giving me more stuff to learn about. Which brings me to my last slide, which is over here. Okay, cool. So one of the things that I found very valuable as I'm doing this is see how other people use it. So there's other people out there who are starting to use this, and I find it useful to just see what's going out there, see what's out there. And you can search GitHub. GitHub doesn't have a great search interface, but you can say type language is Clojure, and you can get stuff like this. So I was looking in the Java JDBC namespace, and I was seeing, like, I didn't know you could do this. You could say, hey, it just didn't even occur to me that you could do that, but that's useful. So this is almost like having a type system a little bit. You can say, hey, is it an instance of this type? And then just, if you go through and look at that, you'll see some other, ways that they are just defining function specs. And also just like this operator means 0 or 1 of the options. So that was useful. So it's always useful to see how other people are doing it. And the final thing I would say is if you're interested in doing Clojure, the community is really great. And if you go on Slack, they will answer your questions. It's pretty amazing, honestly. It's not that large of a community, I would say, but they're good people, so they'll help you learn. And yeah, that's it. This is Spec.